You are looking at the growth of a super thin film of titanium dioxide. Researchers are gaining its growth by adjusting parameters like temperature and oxygen pressure. The researchers want to understand how to create high quality thin materials like this. Those are useful properties for designing next generation materials for catalysis, quantum information science, and microelectronics. But look, minutes into experiment, the diffraction image changed from streaks to dots, an indicator of a rough surface. The experiment has failed. Typically, the research team would adjust the deposition parameters and try the experiment again and again and again. After all, failure is a part of scientific process, but our researchers at Pacific Northwest National Laboratory are doing something different. We are developing artificial intelligence tools to learn how to grow these films better than humans can. When we look at this experiment again, something else is watching too. It is a machine learning algorithm. The research team has programmed the algorithm to analyze these images in real time and detect changes early. Here, the algorithm is detecting an inflection point where the material is just beginning to become rough. At this point, the change is too subtle for the scientist to detect. The algorithm will be connected with the model of the film growth process that is physics informed. That means that it is programmed to understand the physical laws that govern materials. That is important for what comes next. Once the algorithm learns to detect early warning signs of unwanted properties like a rough surface, the model will guide the instrument to change parameters and avoid failure. This is the research team's goal, developing an autonomous characterization and synthesis loop. This is a process where AI can identify the need for intervention and automatically adjust our instruments fast enough to save our experiment. The the researchers hope that AI tools can turn experiments that were headed to failure into successes so that they can reliably synthesize new materials to study. This AI approach could rapidly accelerate the pace of material design. Learn more at pnl.gov.